Introduction to Program Synthesis is a complete new course, which will be offered for the first time in the upcoming winter term. And in this video, I would like to give you a short overview about its curriculum. But first, let me explain what program synthesis actually is or means. It's a field in computer science which aims on an automated search for computer programs which match semantic and synthetic requirements. And the synthesis process is mostly accomplished with a collection of given artifacts, such as input-output examples. And nowadays, the application of machine learning techniques is quite popular in this field. And therefore, program synthesis can be considered as an interaction between synthesis and machine learning. Throughout the course, I also would like to address the timeline or historical background of program synthesis. Its origins date back to the 1930s, and the first thought or first consideration of constructing computer programs automatically or by a machine has been actually proposed by Alan Turing in 1945 in his publication Proposed Electronic Calculator, where he considered the idea of constructing instruction tables by a machine from historical perspective. This can be seen as the first vision or first thought of constructing or synthesizing computer programs automatically. We will also address other historical techniques or methodologies which have been proposed over time, such as deductive and inductive synthesis methods, but also heuristic search algorithms such as genetic programming. And we will also address the modern approaches such as deep learning or reinforcement learning-based methodologies like neural program synthesis or generative AI, such as large language models, which have been trained to produce code. The curriculum is structured as follows. The first part of the lecture will focus on the scope and history of program synthesis. But then we will go into foundations, especially of computer programs. We'll look into the historical background as well as early representations of computer programs. This chapter will also address elements or fundamentals of machine learning and optimization, which are required to understand program synthesis holistically. We will then consider the general principles of program synthesis. We will look into the problem statement and analyze what is actually meant by program synthesis. But we will also look into the respective search spaces, which are used or created by the application of various methods. We will then look into the traditional search methodologies, such as enumerative search, inductive, deductive search, but also the heuristic methods, which are based on a stochastic search. The modern concepts, as I already mentioned, are based on deep learning as well as reinforcement learning, but especially we will look into neural program synthesis as well as generative AI, such as transformers and large language models. The lecture will focus on two concepts. This is learning by demonstration, which means direct learning with examples and the live demonstrations in the lecture itself. We will also focus on an inverted classroom concept by working together on short exercises to make the lecture more interactive and to involve all participants. And the requirements for this lecture are fundamental programming skills in Python as well as fundamental understanding of data structures, numerical analysis, and basic linear algebra. This course will have one lecture per week, which will be on Wednesday, 12:30 to 2 p.m. and one exercise per week, either on Thursday, 10:30 to 12, or that's up to you, in the afternoon, 12:30 to 2 p.m. More information can be found on the website of the Chair 40, and there you will also find a link where you can register yourself for the course in the RWTH online system. I'm looking forward to it, to meet you there, and that's it from my side, and hope to see you soon.